Hello and welcome to day 3 of Unit 9, Reaction Stoichiometry. Today we're going to learn about limiting reactants versus excess reactants. What that means is that you're not going to be doing anything different than what you already have been doing. You're just going to do it twice. So the whole point of limiting versus excess reactants, what's going to happen is you're going to be given both reactants. So you're going to be given an amount for both of the reactants for your reaction, and you're going to have to solve for whatever it asks you to solve for using both of them. So you're going to be doing dimensional analysis twice. That's all it means. And whenever it asks you what the limiting reactant is, limiting reactant, that's the one that produces the smallest amount. So that is the reactant that produces the smallest amount, and that smallest amount is your theoretical yield. That's how much you actually can produce. You can't produce more than the least amount you can make. So whatever the smallest amount that you can make, that is how much your theoretical yield is. So that's like your final answer. But then we're also going to ask you what is the limiting reactant and what is the excess reactant. Well, the limiting reactant is going to be the reactant that produced that smallest amount. Your excess reactant is going to be the one that produced the larger amount. Okay? So, let's go ahead and set this up. So we had talked about how on your quiz and your test, you are going to be given the reaction, but you're going to have to balance that reaction. So, this is your reaction for example 1. Lithium oxide reacts with magnesium chloride. This is what you would get on your quiz and your test. Then you're going to have to balance it. So, we have 2 lithiums over here, so I know that I need 2 lithiums over here. But that also changes my chlorines. So now I have 2 chlorines. Oh, but I have 2 chlorines over here, so that's good. 1 magnesium, 1 magnesium. 1 oxygen, 1 oxygen. So now everything is balanced. So what we're going to do now is we're going to use what's been given to us, 3.5 moles of lithium oxide and 4.7 moles of magnesium chloride. They gave us the amount for each reactant. What that means is we're going to set up dimensional analysis twice. So, it's asking us to find moles of lithium chloride. So we're going to go from moles of lithium oxide to moles of lithium chloride. And then again, we're going to do moles of magnesium chloride to moles of lithium chloride. So we're going to set up, I'm going to start with lithium oxide. So our given is 3.5 moles of lithium oxide. And I need to get to moles of lithium chloride. So what that means is I need to get out of moles of lithium oxide, so I'm going to put that on the bottom. Now I'm in moles, and I need to change what substance I'm talking about, because it's asking for moles of lithium chloride. The only time I can change what substance I'm talking about is when I'm in moles. I'm already in moles. So I can go ahead and just switch to moles of lithium chloride. I'm only changing one thing. I'm not changing my unit, so that means I can change my substance. Okay, now the numbers that go with these, remember this is our mole ratio step. So that's whatever our coefficients are for that substance. My coefficient for lithium chloride is 2. My coefficient for lithium oxide, well, all of these are 1. So we can say 1 mole of lithium oxide. So now we solve for lithium chloride, and we can just plug it into the calculator. When we do that, we're going to have 3.5 moles times 2 divided by 1. That's going to give us 7.0 moles of lithium chloride. So I solved for moles of lithium chloride using lithium oxide. But now I have to solve for lithium chloride again, but now using magnesium chloride. So I'm going to start again, but now using 4.7 moles of magnesium chloride. I need to get out of magnesium chloride. So I'm going to put moles, magnesium chloride on the bottom to cancel it out. And I can do my mole ratio step because I'm in moles. So I can do moles of lithium chloride. Now I'm going to go in and put my coefficients. So my coefficient for lithium chloride is 2. My coefficient for magnesium chloride is 1. So now I would just plug this into the calculator. And when that happens, we're going to get 9.4 moles of lithium chloride. So now we have to figure out what our excess reactant is, what our limiting reactant is, and what our final answer is. Our final answer is the smallest amount we found. So we have 7 and 9.4. Our smallest amount is this. This is our smallest. So it's the limiting and final answer. So this is our final answer. So we can go ahead and put 7.0 moles of lithium chloride as our final answer. Our limiting reactant is whatever we started with that got us our smallest answer. So we started with lithium oxide and it produced the least amount of lithium chloride. So our limiting reactant is lithium oxide because it limits how much we can make. We don't have enough lithium oxide to make 9.4 moles of lithium chloride. We only have enough to make 7. But we do have enough magnesium chloride to make 9.4 moles of lithium chloride. We have more than enough magnesium chloride. So magnesium chloride is our excess reactant. Okay, we're going to do this one more time, but now we're going to go from grams to grams. So we're using the same reaction, lithium oxide plus magnesium chloride, to get lithium chloride and magnesium oxide. We're going from 84.2 grams of lithium oxide and 118 grams of magnesium chloride, and we're solving for grams of magnesium oxide. So we're going to start with our given, this first one, 84.2 grams of lithium oxide. Now, whenever we're in grams, we have to get out of grams by going to moles, and that's molar mass. So the molar mass for lithium oxide, remember we can find our molar mass by using our periodic table. So the molar mass for lithium, let me grab my periodic table. The molar mass for lithium is 6.94. And there's 2 of them. So we can do 6.94 times 2. Then oxygen, the mass is 16, and there's 1. And then we add those up. So 6.94 times 2 is 13.88. So we're going to do 13.88 plus 16 from our oxygen. That gets us 29.88 grams per mole. So 29.88, that's our molar mass. That means 29.88 goes with the grams. And that's for every 1 mole of lithium oxide. So now we're in moles of lithium oxide, which means we can do our mole ratio step. So we can do moles of lithium oxide, and then moles of magnesium oxide, because that's the compound we're trying to find. We use our coefficients. Lithium oxide is 1, magnesium oxide is 1, so they're both 1. So now we're in moles of magnesium oxide. We can now go from moles of magnesium oxide, because we're trying to get rid of it, so we put it on the bottom, to grams of magnesium oxide. We can do this because we're only changing one thing. We changed the unit, moles to grams, which means our compound stays the same. We keep it as magnesium oxide. So now we're back to grams and moles, so we use molar mass. So the molar mass of magnesium oxide mass of oxygen is 16 times 1 is 16. Magnesium, according to the periodic table, is 24.30. And when we add those, we get 40.3. So 40.3 grams per moles, which means 40.3 goes with the grams over 1 mole. So now we've gotten to grams of magnesium oxide, which is what we're looking for. So we can plug it into the calculator. 84.2 parentheses 1 over 29.88, close, parentheses 1 over 1, close, parentheses 40.30, divide 1, close. That gets us 113.5629183. But using sig figs, we have 3. So our final answer here is going to be 114 grams of magnesium oxide. However, that is not our final answer for the problem, because we did this using lithium oxide. But we were also given grams of magnesium chloride. So now we're going to have to do this whole thing again, but instead of doing lithium oxide, we're doing magnesium chloride. So I'm going to start 118 grams magnesium chloride. So if you notice, this is just a gram to gram problem. So we're going to do molar mass, mole ratio, molar mass. Same setup that we did last class. We're just doing it twice in one problem. So we can do grams of magnesium chloride, mole magnesium chloride, but we have to find the molar mass. So magnesium is 24.30. There's 1. Chlorine is 35.45. There's 2. Whenever we add them up, you get 95.20 grams per mole. That means 95.20 goes with the grams. And this is 1 mole. So now we're in moles of magnesium chloride, which means we can do our mole ratio step. Moles of magnesium chloride to moles of whatever we're trying to find, which is magnesium oxide. We come to our reaction to find the mole ratio. Magnesium chloride is 1, magnesium oxide is 1, so both of these are 1. And then this last step is actually the exact same as this last step because we're still trying to find the same thing. So we can go ahead and take this and just copy it down because we're not changing what we're trying to find. And then we can plug it into the calculator. So we'll do 118 parentheses 1 over 95.2, close, parentheses 1 over 1, close, parentheses 40.3, divide 1, close. So with sig figs, 118 is 3. That means our final answer has to be in 3. So instead of 49.9, this 5 makes us round up. So we're going to have 50.0 grams magnesium oxide. So let's remember, our final answer is the smallest. That means 114 or 50. Well, it's going to be 50. 50 is smaller than 114. So our final answer is 50.0 grams of magnesium oxide, which means our limiting reactant is whatever we started with for this one. That would be magnesium chloride. Magnesium chloride limits how much magnesium oxide we can make. So magnesium chloride is our limiting reactant. Our excess reactant is the other one that we did. That's lithium oxide. Excess reactant is lithium oxide. So this is not anything different than what you have already done. All you're doing is setting dimensional analysis up 2 times and finding the smaller amount. That's all it is. So if you have any questions, please come see one of us. We're happy to help you. Otherwise, good luck studying, and we'll see you later.